Hello everybody and welcome back to Advanced Maths. Today we're looking at quadratic inequalities. You should be familiar with quadratic equations, and these are equations with an x squared term, whereas quadratic inequalities are inequalities with an x squared term. We've got a few examples on the screen for you here. In the exam, you will be asked to solve these and find the values of x which satisfy this inequality, and you will present this as an inequality itself. The answer will be another inequality. Solve the following quadratic inequalities. We've got some examples here, and we're going to start with this one. X squared minus 5x is more than or equal to 14. We take 14 off both sides, and this gives us a 0 on one side. This is how you solve quadratics. If you're not familiar with solving quadratics, you need to revise that before we continue this video. I will link that at the top of the description below this video. However, if you are happy with solving quadratics, we can continue. We factorise it, and we get this. And this tells us the quadratic is equal to 0 at x is 7 or x is equal to minus 2, the opposite of the brackets. Now we have solved the quadratic equation. This will help us figure out when it is above and below 0. We can start by graphing this quadratic, and it will look like this on a graph. It will look like a U shape, and it will cross 0 at x is minus 2 or x is 7. We draw a quick sketch of the graph. It just looks like this. It's going to be a U shape because it's a quadratic. Now we're interested in when it's more than 0. So it's more than 0 above the 0 line, and it's less than 0 below. We're interested in when the quadratic is above 0, and it's above 0 where I've highlighted it in yellow. This is below minus 2 and above 7. So the regions that are above 0 are x is less than or equal to minus 2, or x is more than or equal to 7. And that's it. That is the answer. Just notice that the signs in the answer need to match the signs in the original problem. The original problem was more than or equal to, or equal to. So the answer must also have or equal to signs. This is the answer we wanted. It tells us the x values that give an answer that is more than or equal to 14. And we've done. You can check this, of course, by choosing an x which satisfies our equation. For example, x equals minus 3, that is less than or equal to minus 2, and substituting it into the original, and you will get an answer more than 14. And that's just a way of checking that it works. Now let's look at the other one. We're going to move the 6x to the other side to make it 0 on one side. We'll divide by 2 because this makes the quadratic easier to solve. Just gives an x squared on its own. And then we factorise, we get this, which tells us that x is equal to, the quadratic is equal to 0 at x equals 4 or x equals minus 1. You don't have to solve it by factorising. There are other methods to solve quadratics. You can use completing the square, the quadratic formula, or even a quadratic solver on a scientific calculator. We sketch this graph like this. It's going to go through 0 at minus 1 and 4, and it's going to be, we want it to be below 0. We want to know when it's below 0, so we can highlight that in green, and we don't want it above 0, so we've highlighted that in red. The yellow part of the curve is where it's below 0, and that is between minus 1 and 4. And we write that quadratic as minus 1 is less than x is less than 4. The original inequality had a less than sign, so the final answer will also. If here the original was a less than, so our answer also has less than signs. They are not or equal to signs. Again, they need to match the original question. So the final answer is minus 1 is less than x is less than 4. And we've done. That is the quadratic solved. Step 1, we rearrange the quadratic inequality to have 0 on one side. Step 2, we solve the quadratic to find when it is equal to 0. There are several methods to do that. I did it by factorising the quadratic. Step 3, we're going to sketch the graph to visualize when it's above and below 0. And step 4, state the inequality/inequalities, identifying the values of x that solves the inequality. There are two types of inequality we can have. We can have one where there's two separate regions, where we mark those regions with a comma in the middle. That's the example on the left. And there is another type where there's just one region, where it's a number less than x is less than another number. And that's where it's one region in the middle. Let's look at some more examples now. So we've got investigate 3x squared minus 7x plus 1. When is it above 0 and when is it below 0? So we're going to start with visualizing the curve. I'm going to find when it's equal to 0. It's a nasty quadratic and we can't really solve that by factorizing. So we'll use the quadratic formula where a is 3, b is minus 7 and c is 1. We substitute these numbers into the quadratic formula, or you can just use the quadratic solver on the calculator and you get these two values of x, which we can round to 3 decimal places. And we get this. We can plot those as the coordinates of the x-intercepts on the graph, and we can sketch the graph as a U-shape like this. The graph is below 0 between 0.153 and 2.18, and it is above 0 for other regions. So it's less than 0 or equal to 0 there, and it's more than equal to 0 in these regions here where x is less than 0.153 or x is more than 2.18. And we've answered the question, we've investigated the quadratic. I've got one final example I'd like to show you. We're going to solve the inequality 9 minus x squared is less than 0. So we're going to consider the when is it equal to 0, and we're going to factorize the quadratic. We get 3 minus x, 3 plus x. This is difference to two squares. It's a special type of factorization, which you should be familiar with. So when x is equal to 3 or x is equal to minus 3, it is equal to 0. We can sketch those on this quadratic here. The trick is, though, that this is a negative x squared graph, where it's a negative U-shape. It's an upside down U-shape because there's a negative number in front of the x squared. And this makes it a bit trickier. We are interested when it's below 0 here, and that is less than when x is less than minus 3 or x is more than 3. Remember, the style of the inequality must match the style of the original thing. Here, the original inequality was less than, not less than or equal to, so our answer will be less than or more than, not less than or more than or equal to. Okay, we've done. I've shown you all the examples from today. It's now time for you to try some practice yourself. You may want to re-watch the video a few times so you are completely confident with the steps. So here's some practice for you to try. Pause the video now and try this yourself. This will take you at least 10 minutes. So get your calculator and get cracking. Good luck. And when you're ready, I'll reveal the answers in 3, 2, 1. How did you do? Did you get it correct? Let me know how well you did in the comments below. Thanks for watching this week's video from Advanced Maths. Remember to like and subscribe so you don't miss any future videos. We're covering GCSE, A-Level and IB Maths with quick and simple explanations, and new videos are coming soon. Check out advancedmaths.com for more free revision. Thanks for watching and good luck in your exams.